Use the given graph of f of x to sketch the graph of f prime of x. So we're given the graph of a function, and we want to use it to figure out what the derivative is going to look like. When we're doing this, the best place to start is to look and see where we have horizontal tangent lines, because horizontal tangent lines have slope 0, which means at those points the derivative will be 0. Now, if we look, there are 3 places where we've got horizontal tangent lines. I'm not drawing those perfectly, but you get the idea. And so at those 3 points, our derivative is going to be equal to 0. So while we're plotting the points for our derivative, we can plot zeros at those 3 points. All right, beautiful. I don't know if this is meant to be 6 or if this is meant to be a little bit less than 6. It's not exactly clear, but again, just getting a rough idea. So those are the 3 points where the derivative function is going to be equal to 0, because those are the 3 points on the graph that have horizontal tangent lines. Let's look and see what's going to happen in between those. So if we look on this interval here, we can see the graph is increasing. When the graph is increasing, that means that the slopes of the tangent lines are always going to be positive, which means the derivative is going to be positive. So between these 2 points, the derivative is going to be positive in some sense. We don't know how positive, but we can get a little bit of an idea here. The x and the y-axes have the same scales. So if we want to look at the slope of a tangent line, it looks like the steepest it gets is about right here. And that slope to me looks maybe a little bit more than 1. Looks more like a little bit more than a 45-degree angle. So that means the derivative is going to be the maximum a little bit over 1 in that interval. So we can say, I don't know, maybe 1.5 or something like that. And we can see that the steepness starts off at 0, and then it's getting steeper and steeper. And then it stays pretty steep for a bit, and then it gets shallower and shallower until it gets back to 0. So it's probably going to look something like this. All right. Then on our next interval here, if we look between these 2 points, if we look at this part of the graph, it is decreasing, which means that the slope of the tangent lines is going to be negative, which means the derivative is going to be negative, and it looks like this is maybe where it gets the steepest. And that looks to me like the slope is actually a little bit less than 1 in magnitude, so a little bit more than -1. So I'm going to say probably right about here. It's a little bit less steep than we saw in the last interval. This one is less steep than that. All right. And then if we look to the right of this point, the function is increasing very quickly. That means that the derivative is going to be positive, and it looks like it gets quite steep. So that means that the derivative is going to get quite large, so it's going to get bigger and bigger, something like that. And if we're looking on the left-hand side, the same thing is happening as far as it getting steeper and steeper, but it's decreasing, so that means that it's going to get bigger and bigger in the negative direction, and so our derivative is going to look something like that. And so this is a rough sketch of the graph of y equals f prime of x, given our original graph of y equals f of x.